Okay, so now in order to basically, in order to see how a proof is actually done in mathematics, which is not always so easy to understand. Sometimes I was reading a proof, not even a very complicated one, apparently. I was reading a proof I think yesterday, and well, I read the proof twice. I couldn't understand it, and I had to write down the proof on a piece of paper, and then I could somewhat understand what the proof was all about, because sometimes a proof talks about many different things, and then you have to keep everything in mind so that you can actually use logical deduction in order to make sense of that. But it's not always like that. Sometimes it's a little bit complicated, and of course sometimes there are proofs that there are actually proofs that, for example, you hear for example, it's taken, for example, 5 mathematicians. It's taken 5 mathematicians over the course of, like, for example, I don't know, around 800 years to prove something. For example, the other day I was watching a video on YouTube about some famous mathematicians, and for example, and he was a mathematician that he's actually still living. Still living with us. Living is still alive. And there have been this problem in mathematics. Somebody, like, for example, 900 years ago has tried to prove something. Some mathematician, like 1,000 years ago, has tried to prove something. And then after 200 years, some other mathematician has contributed something to that. And then again, after 300 years after that, somebody else has contributed something else to that. And then they have somebody else now, after like 1,000 years, has taken all of those ingredients and added a few things to that. And now the whole thing has become a valid mathematical proof. So sometimes it takes, for example, and the proof actually becomes, for example, like 40, 50 A4, actually 40, 50 A4 pages. You have to just keep writing in order to come up with one single proof. But it's not always that complicated, and it's not always going to take 800 years. But proving things mathematically, in my humble opinion, it's not, I'm not saying that, I'm not going to say that it's not fun. It's not always fun, okay? But again, it's a part of mathematics. You have to accept it as it is. There is no point in not liking it, because it's a part of your work, right? So, now, for example, if you were to prove that the sum of the interior angles, the sum of interior angles of a triangle is 180 degrees. We want to prove this, okay? And that's basically the proof that I actually could not do, or I didn't actually get the solution when I wanted to do it. So basically, in such cases when it comes to geometry, almost always you have to draw a diagram. So for example, since we're talking about a triangle and the interior angles of a triangle, what you do is basically you draw a triangle over here, for example. So you draw a triangle over here, and that becomes your diagram. And that becomes, for example, ABC. Okay? And now we want to prove that the angle ABC, this angle plus angle BCA, this angle over here, okay, plus this angle over here, CAB, these, we want to prove that basically angle ABC plus angle BCA plus angle CAB is equal to 180 degrees. Okay, that's what you want to do. Now this is now the part where you have to put together some sort of solution, and then what you think might work in this case, and then use that solution in order to solve the problem, or in order to prove what you want to prove, which is basically this statement over here. So what I can do here, basically I can use the concept of parallel lines and transversals in order to solve this problem. So I can simply draw a line parallel to BC. I can simply draw a line parallel to BC over here, and then I call this, for example, point. I call this is a line. Okay, so this is a line, and I call this point, for example, point D. This point I call it point E, for example. So I'm doing everything based on the diagram. And so then, now having this diagram, you can start basically working on diagram and start writing the necessary steps in order to get to this statement, because you simply want to prove this statement. So now it's not usually enough to say, to just basically think to yourself that, for example, of course, if you're doing something just for yourself, that would be no problem. But usually if you want others to be able to follow your work and use your work in different situations, you have to write down the details. For example, you have to write down, for example, construct a line DE parallel to BC, for example, through A. So you have to write this meticulously. For example, construct a line DE, okay, a line DE parallel to BC through A. Okay, so you have to write things down this with so much care and with basically so much care. Okay. Now, so now DE is parallel to BC. DE is parallel to BC, and AB is transversal, right? So AB is transversal. So what that means is that basically this angle over here, that means this angle over here is equal to this angle. So DE is parallel to BC, and AB is transversal. AB is transversal. transversal. So angle DAB, is equal to angle ABC. Angle ABC are alternate angles on, these are called alternate angles on. So these are not actually, there are two different kinds of angles there. These are called corresponding angles and alternate angles. So these are called alternate angles. Now but I don't want to talk about that. So of course you're not supposed to actually write it like this. Now let me actually do at least this one right. So then what you actually need to do, I mean the way that you're supposed to do it is you write so angle, for example, angle DAB, meaning this angle over here, and angle, for example, ABC are alternate angles. Okay, so therefore, for example, by for example such and such theorem, that for example you're based on some book, for example, or based on some literature that you're referring to, by such and such theorem, which is basically related to parallel lines and transversals and so on and so forth, and this is something that has already been proven. Okay, by such and such theorem, they are equal. Okay, so that is, i.e., so angle DAB is equal to angle ABC. So then you can write that, and of course you can mark your angles there to show that they are actually equal. And then you can write, for example, you can write similarly, meaning by the same logic, this angle over here, this angle over here, ACB, angle ACB is equal to angle EAC, meaning that this angle is actually equal to this angle. Okay, CAE is equal to ACB. So then the next step would be therefore angle ABC, this angle over here, plus angle BAC would be this angle over here, plus angle ACB is equal to these three angles, because this angle is equal to this angle, this angle is equal to this angle, and this angle is common between the two sets of angles. So therefore you can write angle ABC plus angle BCA plus angle BAC is equal to these three angles put together, because this angle is equal to this angle and this angle is equal to this angle, and that is common. So you can write angle DAB plus angle BAC plus angle CAE, or basically CAE. Okay, and usually it's a good idea to write your angles in one single orientation, meaning that if you write this angle as CAE, meaning that for example, this angle over here, you can write it as CAE and also as EAC. This angle over here, you can write it as EAC, angle EAC, and also CAE, angle CAE, and both of them would be the same angle, would refer to the same angle. But when it comes to writing your angles this way, it's actually a very good idea to write them in just one orientation, because then when it comes to simplifying things, if they are written in different orientations, that would simply basically confuse you, meaning that, for example, if you had these two angles on different sides of this equation, you would of course simply cancel them out, because they are the same exact things added to different sides of this, to the two sides of this equation. But if they are written in different orientations, you might actually not see that. So that's the problem. Okay, I have had this. I'm personally in a love-hate relationship with geometry, and I actually had to go through so much pain in order to go through my basic geometry in circles and triangles and parallelograms and rhombus and rhombi and things like that. And it was actually not very fun, but well, and I actually did learn a whole bunch of such things over there, that, for example, you have to write your angles this way or that way. But of course, all of these concepts, for example, when it comes to let's say that I don't know, for example, my work is, sometimes I do a couple of things in electronics. These kinds of things, if you don't know them properly, you will not be able to do much in your work, whatever that might be it, for example, physics or electronics or whatever else that you might be doing. So these are the very basics of anything you might do. So you might as well take your time and actually learn them, because there's really no other way. Okay, so now in this step we wrote that basically the internal angles of this triangle is basically the sum of these three angles is equal to the sum of these three angles over here. And now you can write but, and these words are important, so you want to actually use them right. For example, here I've written similarly, here I've written therefore, here I've written but. If I don't use this word, people might get confused. But when you use a single word which is suitable to that situation, people will understand that why actually you have used that step in that particular place. So you want to use them, and you want to use them right. Okay, so now but angle DAB, which is basically this angle over here, angle DAB plus angle BAC plus angle BAC plus angle CAE plus angle CAE is equal to 180 degrees, since they form a straight angle. You don't really need to write, for example, since they form a straight angle. You can simply write here in a pair of parentheses. You can write, for example, form straight angle, something like that. and that's enough. Okay, so you want to find the right balance between writing everything down and sometimes not writing the words that you don't need to write, because you don't want to make your proof too crowded. Okay, so then angle DAB plus angle BAC plus angle CAE is equal to 180 degrees. So, and you want to use basically punctuation also, right? So for example, I write but, comma, so, comma, and so on and so forth. So then angle ABC plus angle BCA plus angle BAC is equal to 180 degrees. And that's basically what you wanted to basically prove here, what you wanted to prove here. Okay, so that's basically a valid proof in mathematics. So now about the steps that we have taken. If you were to talk about this briefly, so for example, in the beginning we started with a diagram, and since the whole problem was about the internal angles of a triangle, I started with a simple triangle over here. Okay, and basically then you have to somehow think about the step 2 that we did before we started writing down these things over here, was that basically we drew this line over here parallel to BC, and that was not basically based on I did not draw this line just like that. I drew this line because I had a plan, and my plan was that I wanted to use the properties of parallel lines and transversals and things like that in order to basically continue with my proof. So then I drew this line over here in my diagram, and then I started to write over here. So basically already at this step I already knew what I wanted to do, and then you have to go through the steps one by one in order to get to what you want to prove. And then for example over here, the important thing over here we said that basically you have to write some necessary information that, the information that I wrote over here was actually necessary, meaning that if somebody wants to read your proof and understand it, they're supposed to understand, for example, what sort of line this line is. If you draw a line in your construction in such a way that you actually assume that basically the line is parallel to, for example, BC, then you have to write it over here and write it in such a way that people understand it, meaning that you write, for example, construct a line DE parallel to BC through A. That basically takes care of all the explanation that is needed at this stage. And then you start with the logic that needs to be that needs to be basically laid out here, meaning that you start saying that, for example, these two lines are parallel and this line, for example, is a transversal, so then these two angles are equal, and then by the same logic these two angles are equal, and this is based on, for example, such and such theorem that we have proved before, or based on such and such theorem that we know is actually true. Okay, so then we came to the conclusion that, for example, these two angles were equal and these two angles were equal, And then basically another line of logic that we wrote was that, for example, the sum of these three internal angles is equal to the sum of these three internal angles, and then based on that we concluded that the sum of the internal angles of the triangle was actually 180 degrees. So that's basically a complete mathematical proof, and it's not too hard, it's not too trivial, and it gives you all the necessary steps that you need to understand in order to prove something in mathematics. Okay, now let's see if I have. Now I don't want to give you unnecessarily more examples over here. I don't want to basically unnecessarily give you more examples over here. We have a couple more things to cover. We have basically a couple more things to say about mathematical statements and things like that. And you don't need to worry about examples. You will get enough examples in the actual basically work that we are going to do. The purpose of basically these videos is just to understand how to prove things and to understand the basic structure of mathematical proof. Other than that, right now we don't really care about triangles or circles or numbers or anything in particular. And again, for example, the purpose of, for example, this particular example was just to show basically the logical steps that take us to the logical conclusion that we wanted to prove here. Okay, so now in the next video we will have a couple more things to discuss, about the same thing. So I'll see you in the next video. Thank you.